not working.
Hello everyone, मेरा बच्चा लोग कैसे हैं सब? And before I start with everything, I think this is our first class in this amazing new year, right? So first of all, let me wish a happy new year to each and every बच्चा लोgs in the classroom, right? I hope you all are so much excited for this year, right? So just like you all, I'm also totally excited. I'm also thinking so much of surprises for me from this particular year. Okay, I have thought about so much of things to be done in this particular year. I want to make this so much wonderful, right? So you also make your own dreams, okay, and make your dream come true. And obviously, let's have this amazing happy year super wonderful, isn't it? Right. Now, bacha log, let me say hi to everyone here. Let me say hi. Hi Prashant, hi Nancy, it's cute Tanya, good evening. Hi Palak, good evening. Happy वाला न्यू ईयर और क्या बहुत हैप्पी वाला राइट राइट अभय शिवाली यांत्या अरे हेलो एवरीवन हाय वेयर इज द जोश अब सब लोगों का जोश का है वेयर इज दैट एनर्जी एंड वेयर इज दैट एक्साइटमेंट everyone here is super duper excited और क्या let's go and let's make the session super awesome right Myaras hi Suti Palak a big hi to everyone. Now, what makes this particular session more awesome other than this is happening as the first class in our new year? Yes, this is the very first class of one of the amazing chapter which is wave optics. Now, let me tell you beforehand, okay? It's an amazing chapter, it's an important chapter, at the same time it's a bit difficult chapter among all the other chapters of part 2 physics. So what we have to do, we have to give more importance, more time, and we have to go with the concepts in deep. I'm totally ready for that. Are you all ready? Right? For this particular session of wave optics, for the very first class of wave optics, right? Okay, amazing, very much. Hello. So whoever is seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and a bit of introduction about myself. I hope you all can see on the screen, isn't it? So what is not written on the screen is I'm from Kerala, मेरा बच्चा लोग. I know Hindi, but I'm not so good in it. ठीक है? So I'll be explaining all the contents in English, लेकिन like I say in all my classes, है ना? छोटा मोटा बातें हिंदी में भी हो जाएगा, ठीक है? And if I go wrong, you can make fun of me, ठीक है? It's totally fine. Okay, so moving on. Now, bacha log, if you don't want to miss any of the live classes from your favorite teachers of Unacademy class 11th and 12th, the link is given here for the Telegram channel and also in the description box. Don't forget about it. Okay? So, yes, Bugs Bounty, what it is? Bacha log, it's an amazing program which can help you get so much of prizes. What do you have to do? Go to the description, there you'll find a form. Click on the form and fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा prizes मिल जाएगा आप सब लोगों को. Now, बच्चा लोग, those who haven't heard about how beautiful and amazing Unacademy is, this is your chance because CBSE Mega Compact exam is going to happen and what is the specialities and benefits that you're going to achieve from it? Lot many. Okay, lot many matlab lot many. What all? First of all, registration to this Mega Compact test is completely free. But to enroll it for free, you'll have to remember a small code. Do you know what it is? Shall I write it for you? Okay, then give me a minute. So that simple code you all have to remember is AMB10. I hope you all can see, right? So while you get enrolled for this Mega Compact test, just type in this particular code AMB10 as your enrollment code. You can get enrolled to this compact exam completely for free. I haven't completed with the benefits, what all you are going to enjoy. For the first 3 rankers, right, not just certificates, medals are also given. First rank with gold, second with silver medal, and third with bronze. Are wah! You all know how much worthy is gold is nowadays, and how much pricey it is. So don't miss your chance, Manoj. For the first 25 rankers, certificates are also given. Not just that, dekh le, what all? Mobile phone, laptop, headphone, JBL speakers, Google Home Mini, Amazon vouchers, sab. Right? So what you need to do? You just need to come on 9th of January at 1 p.m. give this particular test and enjoy this amazing compact test. right? So I hope you can see the subjects, right, and their respective topics. This is for class 11 and this is for class 12. I'm expecting every one of you. Next week I'm going to listen amazing beautiful stories from every one of you regarding this. ठीक है? Now, okay, yes. Now, chalo, I'll take 2-3 more minutes for explaining this Unacademy Plus subscription platform. Just 3 minutes. Can you do a small thing for me within that time? Chalo, कर सकता है क्या? हाँ? A chotu wala thing. Can you all do that? Nothing, but I just want every one of you to share the class to all your friends and ask them to join as soon as possible. Tell them Bhaiya has started already the classes of wave optics, and tell them this is very important, very difficult chapter, but we are going to make it super easy. So tell them not to miss any of the classes. Done, Palak? Right? Already here, Miara, Evelyn, theek hai? So I'm expecting everyone to do the same. In the meanwhile, bachalo, if anyone is to the Unacademy platform for the very first time, I'll explain what are the super amazing features you're going to enjoy once you're a part of Plus subscription and why you need to go for the Plus subscription. ठीक है? Bachalo, isn't nowadays everything freely available on YouTube, right? Obviously, yes. Even we are learning through YouTube nowadays. But there are some students who would love to have a personal guidance or mentoring directly from the teachers. If you want that, the best platform is the Unacademy subscription platform, where you can directly chat with your teacher or the educator and get your doubts resolved on time. More than that, I know that you all do love to get your doubts solved on the spot whenever a teacher is taking live classes. I think that's a dream of all the students, right? So in the Unacademy Plus subscription platform, there is an amazing feature called as in-class calling facility. Matlab, you can call your educator at the moment whenever he is taking the live class, get your doubts resolved in the classroom itself. Isn't it super amazing? Yes, it is. I haven't completed. Then top educators of the country who's having a very good experience will be there to teach you, right? They'll be knowing what are the examination pattern, right? What all MCQs you should be practicing. You just follow them, right? You're gonna ace in all the competitive examination, and yes, you will be going into the colleges whichever you are dreaming about. Then study materials will be given, practice test, live test series. Everything is gonna make you super great and super confident. And but chalo, if you go for 12-month subscription, it will cost you 1,250 rupees per month. But my question is, do you really need to pay that much? No, because we have the code for the entire physics family. We as a family of physics use this code of AMB10, and are we going to just get 10% of discount? No, New Year ka season hai. So this is the very last day mera bachcha log, 2022. So 22% of discount if you use a code of AMB10 from the price already mentioned. 22% off. Wow. Isn't it awesome? So don't wait now itself, because the day is almost going to end, because the last day is 3rd, right? And we have one more subscription iconic. Chalo. So here we'll get all the features of Plus subscription. More than that, you'll be given a personal mentor. Matlab, a person will be assigned to you for all your academic activities. He'll be there to help you with everything from A to Z. You'll feel so free and cool when this person is there with you. Then live out solving classes, weekly report, right? Don't you think all these features are super cool? And if you want to enjoy this, if you go for 12 months of iconic subscription, it will cost you 2,333 per month, mera bachcha log. And again, do you need to pay that much? Bilkul nahi. Because we have our code of AMB10, theek hai? And is it just 10%? No. New year 2022, 22% off. Don't forget it. Jaldi se, this is the last day. Make use of it. Okay? Done. Now, that's all about. Now, I want to tell you, bachcha log, special classes are going to happen on 5th of January, where we can revise the entire ray optics, bachcha log. Okay, it will be happening on 5th of January with part 1 and 6th of January part 2 special class. Don't miss. Okay, you all know the code again, AMB10. Special classes are completely free. It happens on an Unacademy app. Don't miss it, right? Because your study will only be complete once you attend all my YouTube classes plus the special classes. Theek hai? Okay, part 2 is on 6th of January, like I told you. Now it's time to get started, and let me say, or let me ask, are you all ready? Bachcha log, are you all ready? Kya? Let me see how many of you are super ready. अरे एवलीन, मैं तो बिल्कुल बढ़िया. Thank you so much for that love and that super energy you are giving there. Speak Bengali sir, cute तानिया. हाँ हाँ बिल्कुल बिल्कुल, अभी अभी. ठीक है. अरे give me some time to learn Hindi at least. Okay. Okay, so everyone ready? Shivali, Subreen, Shraddha. ठीक है. So I hope everyone is ready with a Chotu book, and with this beautiful, amazing pen. Then write the heading everyone. Our chapter, it is wave optics. Now you can ask me, Vacha, look, what we are going to learn in this particular chapter of wave optics. It's very simple. Right? In ray optics, we have learned some phenomena of light. What all were they? Reflection of light, refraction of light. Similarly, we are going to learn some of the phenomena of light here in the chapter of wave optics, such as interference, such as diffraction, right? Such as polarization. But here, for understanding and learning these new concepts of light and phenomena of light, we are going to consider light as a wave. Arey, baap re, aise kaise? Because the same person, your Ameer Bhaiya, has told that light is traveling in a straight line in which chapter? In the chapter of ray optics. Now, the same Bhaiya is telling that we are going to consider light as a wave essay, or light energy is being carried in the form of a wave. So, is it a contradiction, or do you think that just in order to explain some of the concepts, Ameer Bhaiya is here, right? And whenever he needs, he is considering light as a wave, and other time he is consider it is moving in a straight line. Is that so? No. There is a very good connection between this. Whenever I took ray optics chapter, I have actually explained. Koi baat nahi. I know that there are some new students here. For them, I'll explain once again. Okay? Why in the chapter of ray optics we are considering light is traveling in a straight line, and why now we are considering light as a wave. Shall we do that? Okay, everybody listen. Everybody. Okay? Now you don't have to think about your notebooks, pen, kuch bhi nahi. Just listen to me here. We have a point A. Okay? At the point A, I'm having a source of light. Source of light matlab torch. Okay? Bulb, anything, right? So I'm having a torch here for the time, namesake. Okay? I hope it looks like a torch. Now chalo. Okay? Torch. Now what I'm going to do, I'm switching this particular torch on. Kya ho jayega? Light will start blowing and glowing, right? And we can have the energy of light traveling from this particular torch in the form of a wave like this. Light actually travels, or light energy actually travels from the source in the form of a wave like this and reaches the point B. Okay? Now, just look here. Carefully look here. It started from the point A, isn't it, mera bacha log? Okay? And where did it end right now? Tell me, where did it end? At the end point B. Now, if you just look at the net displacement of energy, what is it? If you just observe the net displacement to the energy, in which direction it is it actually making a wave-like motion? No. The net displacement of the light energy has traveled from the point A to B in a straight line. Okay? So, in the chapter of ray optics, what we were actually doing is, we were actually approximating the motion of light energy as a straight line by considering it, or by equating more to the direction of displacement of energy. Okay? We were actually like approximating, okay, in the chapter of ray optics, that light is traveling in a straight line like this. Is it actually traveling in a straight line? No. But what we did with the chapter of ray optics, we approximated by looking at the net displacement of energy's direction. Okay? But this was more than enough to explain some of the phenomena which all reflection of light, refraction of light. This approximated direction of light energy was more than enough for explaining reflection and refraction. But when it came to some of the other phenomena, such as interference, which we'll be learning in this particular chapter, such as diffraction and all, we were not able to explain these kind of phenomena with this approximated direction of light energy traveling. So in this chapter, we are going to actually consider light as a wave. Matlab, light is a wave itself. Okay? And we are going to consider light as a wave itself, and we are going to explain all the phenomena of light, not only interference and diffraction, by using this wave concept. And now chalo, we are going to explain reflection, refraction, interference, diffraction, and everything. Okay? Now I hope you got an idea, right, why we are learning optics as two different topics and what is actually happening there. Okay? And let me warn every one of you, but chalo, this is a conceptual chapter. Okay, so we'll be having until we enter into next class, we won't be having much numerical questions. But at the same time, I want every one of you to note down, listen to the class properly, because without today's class, without the concept from today's class, kal ka class, nothing ho jayega. Matlab, you won't understand anything. So shall we enter into the actual topic? Shall we enter? Right? Okay. So again and again, I'm telling you, the concepts are very important, whatever we are doing. Okay. Preeti, Sudeep, Lakshmi. Okay. Noting along with me? Okay. Now, we're going to proceed further. But chalo, the wave nature came into existence after many years later. Do you know what was the first theory that was existing related to light? Anyone? There was a very popular idea was there. Okay, a very popular theory was there related to light before the existence of theories of light related to wave. Do you know what it was? It was called as corpuscular model. Corpuscular model of light. Okay, do you know this famous theory who invented? One of the greatest and famous person. Yes, without this person, physics 11th and 12th physics is nothing, Newton's. So it was Newton corpuscular model which was so popular before the wave theory of light came into existence, right? Because obviously it has to be popular because the person, the scientist is so popular. So at those times, whatever the Newton said, everybody was ready to believe. Do you know? Okay, what all were said in this corpuscular model of light related to the light energy and how it travels? Shall we? Dekh le. In the corpuscular model, Newton told that light energy he said light energy means a stream of particles. He said light is actually a stream of particles, which means, let's say here I'm having a torch. You are switching on this particular torch. From the torch, he said that so many particles of light are coming out, and it is this particular particles which is carrying the energy. This is what is being said in corpuscular model. And a name was also given by this person, Newton, to this particular particle. Do you know what it is? It is called as corpuscles. Okay, he actually given a name also for these particles which is carrying the light energy. What it is? Corpuscles, right? Everyone was happy, everyone believed also. But one extra thing that he added along with the corpuscular model, right, made people to understand that this one is wrong. Do you want to know which one it is? Right, I'll just tell you. Let's say we have two mediums, air, okay, and water. Tell me, light can have a larger velocity where? In air or water? Okay, in air, which is a rarer medium, or in water, which is a denser medium, where can we expect a larger velocity for light? Jaldi se bata. Everyone, just tell the answer in your mind only. It is obviously in air, right? It was obviously in air, light is having a larger velocity. Okay, we all know that, because when it comes to water, right, because of the high density of the water, light particles or light will be moving slow. But in the corpuscular model of light, Newton actually told in the vice versa manner. In corpuscular model, right, he said that it is in air, or in general it is in rarer mediums, light is having smaller velocities, which is just the reverse. Okay, so it was later found out that it is in air, the light is having a larger velocities, and it came to a conclusion that corpuscular model of light is not the real one. Okay? Now, once it got failed, then the new law was accepted by people, which was given by Huygens, and which we know it as Huygens Principle, which is the wave model of light. Okay, so the corpuscular model was outdated. People came to know that it was wrong whatever it was being told. Okay, so it was being outdated, it was being taken away, and then there comes the wave model of light under the heading of Huygens Principle, which is going to be the entire topic of today's discussion. Okay, everyone understood which was the law before Huygens Principle? समझ में आ गया सबको? ठीक है. And what we are going to learn now, is that also clear? We're going to talk about Huygens Principle. Clear? Don't worry about the notes, मेरा बच्चा लोग. As you all know, I'll be updating the notes in Unacademy Class 11th and 12th Telegram channel. So I hope everybody is there. ठीक है? So just download the PDF from the group. ठीक है? मेरा full concentration noting. Sophia, hi. ठीक है. Now, shall we start with Huygens Principle, everyone? It's very important, right? And if you understand this concept of Huygens Principle, the remaining topics you can just continue. But if you are not ready to listen to the concepts of Huygens Principle today, tomorrow's class, or if you attend any of the other classes, you will find it difficult. So tell me, are you all ready? So you're the best, Vimal. Thank you so much. So are you all ready for it? Are you all ready for starting and learning this Huygens Principle? AMC motivation. Hello, Lakshmi. Yes. Okay. Now, I hope you all have written down Huygens Principle. ठीक है. Okay. Now, whenever you go to any class, right? Whenever people say Huygens Principle, they just keep telling you Huygens Principle, right? They just read the statement, but you won't be getting an idea what this Huygens Principle is. Okay, that is the main problem you will be finding with this particular chapter of wave optics. You won't be able to understand what you're learning here. Right? You'll be learning something like this wave friend, interference, diffraction, but you won't be able to understand why you are learning this. You won't be able to get a connection like you have learned the chapter of ray optics. So understanding each and every term is very important. Okay? So we are going to do that in the exact same way. I want every one of you to be there. 15 minutes, just give me. I'll explain the entire concept of a Huygens Principle in a beautiful way. Okay? Yes. Now, before we start with what is Huygens Principle, right? What are the statements of Huygens Principle, right? I have to tell you how to learn this Huygens Principle, right? What is actually meant by this Huygens Principle? Okay. Now, corpuscular model was outdated. It was taken away. Okay. Wave model of light came into existence. So, Christian Huygens, one of the amazing scientists, he came up with certain assumptions and certain statements and facts. Okay. And these assumptions, statements and facts are noted under Huygens Principle. He told, you just have to believe me and agree with all the statements given under the heading of Huygens Principle. Once again, he told to everyone, you just have to believe with all the assumptions and statements and facts from this Huygens Principle so that we can explain all the concepts, all the phenomena of light, whatever is happening in the nature. Okay? Which means, just like 1 plus 1 is equal to 2. Are you going to ask me, Q sir, why 1 plus 1 is equal to 2? No, right? Just like that, we are going to give out some statements from this Huygens Principle, right? You can't ask why, because you can't even ask why to Christian Huygens also, because he told that you just have to believe this, you just have to agree to this, then only we can explain all the phenomena of light. Okay? Matlab basically we have to by heart this. Shall we start by hearting this? Okay? Huygens Principle. If you start thinking ये Huygens Principle क्या है, you will end up having so much of doubts. Don't do that. right? So just learn and write down whatever I teach you, right? More than enough, right? Okay, I'm going to teach you everything what is there in NCERT. Okay, everyone listen. How many of you have visited a river or a pool or anything, let's say? Obviously, I was having this habit, and when I was a child, I used to go to river, for taking bath, and it's so good with friends. But when you after the bath, if you just sit along the banks of the river, if you find some stones, what do? I just throw into the river, what you can see? You can see ripples, Can't you see ripples like this? Isn't it? Yes, we can see. What are those ripples, मेरा बच्चा लोग? मतलब, if you are dropping a stone at a particular point on the water surface, water waves are being formed in all the directions. Water waves will be formed in all the directions in that particular plane. Can you see that? Okay. Essay. Okay. So water waves are being formed from that point wherever you put that particular stone, isn't it? Yes. Now, haven't you all learned the chapter of alternating current? Yes. Now, tell me, if I draw a wave like this, and if I consider a point on the crust, tell me what is its phase angle? Tell me what is its phase angle, मेरा बच्चा लोग? कितना है? Phase angle कितना है? Should I look into the chat box? Should I look into the chat box? Who's going to tell me what is the phase angle of a point on the crust of a wave? No one? No one is going to answer? कोई नहीं? Yes sir, बस आप term 2 आपका भरोसा है और क्या? भरोसा कभी नहीं टूटेगा. Very good. Pi by 2, or in simple words which everyone can understand, it's 90 degrees, isn't it? Right? Isn't that the phase angle of that particular point? Yes. Phase angle is 90 degree. Very good. Similarly, देख ले मेरे बच्चे लोग, everybody listen here. Everybody. Now, similarly, if I collect all the points of the wave, देख ले, I'm collecting this point, black eye, ठीक है. I'm collecting this point, this point, this point. मतलब, I'm collecting all the points from all the waves which are at an angle of 90 degree. Now, if you connect all these points, what is the shape you're going to get, मेरे बच्चे लोग? What is the shape you get? We get a circle, right? This itself is defined what is as a wavefront. So, a new definition is being given by Huygens. It is on the basis of the name wavefront. What is wavefront? In general way. It is the collection of all the points which are having the same phase angle. Okay, that collection of all the points, or we also say the locus of all points, right? From the part of physics, from the part of mathematics, right? The locus of all points which are at the same angle, we call it by the name of wavefront. We call it as wavefront. Is there going to be only one wavefront for this particular ripples of water? No. You can actually connect all these troughs, है ना? देख ले. All these troughs are at the same phase angle. What is the shape you get? You get another circle, which is another wavefront, right? You can connect all these points which are at the same angle. You get another circle. This is going to be another wavefront. ठीक है? समझ में आ गया सबको? What is a wavefront? Have a look at it and try to repeat the same thing in your mind and just check whether have you understood this concept of wavefront or not. ठीक है? Okay. Fine. Okay. Now, I have explained wavefront only from this concept of ripples of water. Now, shall I take the concept of this wavefront and put into the concepts of our wave optics part, right? Or the wave nature of light. Shall we do it? ठीक है. देख ले बच्चा लोग, I have a source of light. मतलब, let me say I have a bulb here. Source of a light. Okay. When it glows, tell me what happens. Yes. Light energy will be given out or released from the bulb in the form of waves like this in all the directions. है ना? ऐसे. Okay, in all the directions, the light waves will be emerged. Now tell me one simple question, right? Is the shape of the wavefront going to be a circle here? सोच कर बता. Everyone, just think and try to tell me. What is my question? Just like ripples of water, I'm just considering a source of bulb. ठीक है? A source of light which is a bulb. And if it glows, tell me what happens. Light waves will be emerging. My question is, if we collect all the points which are at the same phase, is it going to be a circle in this case, or is it going to be having another shape? Jaldi bata. Which one it is going to be? Everybody can simply tell this, but you have to start imagining things. Okay, you just have to picture everything in your mind. Then only you'll get it. Circle ही होगा. Sabrine is like same. Are you sure? Maybe circle. Definitely not. Nobody is thinking. Nobody is thinking. अरे पूछ ले. Think. Okay. Just think that. Okay, where? Okay. So this tip of my finger is an LED bulb. Okay, I have some supernatural power and I can give some light energy from the tip of my finger. Okay, so suddenly my finger started to glow. Tell me what happens. Waves will be emerging in this direction. Okay, waves will be emerging in this direction, upward, either. Matlab, waves will be spread not in a plane, in the entire space, in the entire three-dimensional space, the waves will be emerging. Now, if we collect all the points, are we going to get a circle or are we going to get another shape here? Now, I hope you all got it. Just think what kind of shape you get. Jaldi bata. Now I want everyone. Array Evelyn Kaur, there you go. It's a sphere. Amazing. It's sphere, not cylindrical. Sphere. Right? Isn't it sphere? Array, from a point, okay, you collect all the points which are at the same distance. I say, here you have points, here you have points. So, what is it going to be? Everywhere you have points like this which are at the same distance. Isn't it going to be a sphere? Isn't it? Yes or no? Simple as that. Yes. So, if we are having a point source of light, okay, what is the shape of a wavefront going to be? This is very important. Questions can come directly as it is going to be a sphere. Okay, what is it going to be? It is going to be a sphere. Very important. Okay, very important matlab very important. Ripples was only there in one single plane, but in the case of source of a light, the waves are traveling in all the three-dimensional direction. Okay, so it will be having a spherical shape. Okay, simple hai na? Aur kya? Now just try to think, imagine. No issues, I hope. Note down everything. Okay, now moving on. Same point source. Okay, just now I have told you, if you are having a point source of light, it will be the spherical wavefront what we can observe, right? But just think that if you keep on drawing so many wavefronts, and if you consider a wavefront which is very far away, okay, a wavefront which is very far away from the point source, what can you approximate the shape of a wavefront as? Dekh le. I'm considering a wavefront very far away from the point source. Okay? As the sphere goes away from this point source, you can see that the curvature is almost decreasing. It is not having that much of curve with the sphere, isn't it? Matlab ye hai ki if you reach at this spherical wavefront a very large distance, you will find the surface of the sphere as almost parallel or just like a plane. Matlab ye hai ki what I wanted to tell you is, right, in the case of a point source, if you consider a wavefront very far away, I'll write it down. Far away, upar ja, far away wavefront if you have, we can almost approximate it. It's a sphere, but we approximate it as a plane wavefront. Okay? We approximate plane wavefront. So we have learned two different kinds of wavefronts in today's class, and this is more than enough. ठीक है? One is a spherical wavefront, ठीक है? And when we go very far away distance from the point source, we can approximate this spherical wavefront almost to as a plane wavefront. Approximation it is. ठीक है? Fine. Is the Huygens principle clear till here? Huh? Is the Huygens principle clear till this here? बोल दे, जल्दी बोल दे. With a smile I want. हो गया तो हो गया, समझ में आ गया. हाँ ठीक है, बढ़िया सबरीन म्यारा, क्रिस्टल क्लियर. और क्या चाहिए, है ना, जिंदगी पे और क्या चाहिए. यस, अच्छे से क्लियर हो गया एवलीन, बढ़िया बात है. Now I think we all can proceed with Huygens principle. Are you getting bored with the concept by listening to so many concept? Bored है क्या? How many of you are like, oh sure, it's so boring? ऐसे कर रहे क्या? No, right? Don't worry, at 9 o'clock I'll be singing a song for every one of you. Will that be good? Will it bring back some energy from every one of you? First song in this new year. ठीक है? No sir, super interested. अरे वाह, बढ़िया बात है, कमाल है. It's must. अरे वाह, ठीक है. So anyway, I have made my offer, a small song at 9 o'clock. If I forget, do remind me. ठीक है? Okay, at 9 o'clock. अभी तो we'll continue. Okay, ठीक है. Now, these are not just the principles of Huygens. We have 2-3 more principles. Shall we continue? देख ले. Now, what are the other approximations and assumptions that was made by Huygens? We're going to continue with the approximations and assumptions made by Huygens. ठीक है? He just made an assumption ऐसे, and we are here learning the same. ठीक है? And that's all about learning physics. Sometimes, है ना? ठीक है. Now, what is said by Huygens? Now, we are having a source of light. Okay, a light source. Now, just now I have told you the shape of wavefronts. How it is for a point source? It is going to be a sphere, isn't it? Yes. Tell me, if you have this light source, in what direction a ray of light will be traveling? Because this is also important to connect between ray of light and the wave concept. It's very important. Tell me, if this is a source of light, right? How a ray will be traveling? A ray will be traveling ऐसे, है ना? A ray will be coming out just like that. A ray of light. Okay. Now tell me how a ray of light and a wavefront is actually connected. What is the relationship you can find in terms of angles? Yes, it's very simple, right? If you draw a ray of light, it will be exactly feeling like you are drawing a radius to this particular spherical surface, isn't it? Yes. Now, we all know the radius is always perpendicular to the spherical surface. इसका मतलब ये है कि, what is it? Yes, a wavefront, ये हमारा wavefront है, ठीक है? A wavefront, and this is a ray of light, है ना? The ray of light are perpendicular to each other. One of the super important concept, मेरा बच्चा लोग, super important concept. Because for understanding the remaining concept, this is very much necessary. Very much matlab very much necessary. What is it? A ray, okay, perpendicular to wavefront. Everybody note कर ले आपका छोटू book पे. जल्दी से फटाफट note कर ले. Ray is perpendicular to wavefront. A ray of light. Okay, ठीक है. Now we're gonna continue. Next assumption, what he told. Okay, what was Huygens told? Can you see different points on this wavefront, hai na? Okay, here we have a wavefront. We'll be having so many points on this wave, innumerable, infinite number of such points we can see on the wavefront, right? And what he told was, Huygens told that all these points on the wavefront will be acting as what, mera bachcha lo? It will be acting as a secondary source. Matlab, all these will be acting like a secondary torch here. Okay, this is what is said in Huygens. Are you going to ask me, sir, why? No, I have already told you there is no point of asking why. Just like 2 plus 3 is equal to 5. Hai na? So there is no point, because all these are assumption. We have to believe, because if we believe to all these assumptions and hold to it, then only we can explain all the phenomena of light. Okay? So what he said, these are the secondary sources. And if it's a source, what will happen? Obviously, from the source, waves will be emerging, right? Another set of waves will be emerging like this. Okay? And these waves emerging from secondary sources, we are giving another name. नाम क्या है? Secondary wavelets. Okay, secondary wavelets. Very important, मेरा बच्चा लोग. Secondary sources and the waves emerging from that, secondary wavelets. ठीक है. Now, tell me मेरा बच्चा लोग, जल्दी से बता. If these waves, okay, if this light waves are having a velocity of v, what is it? If they are having a velocity of v, how much distance all these waves will be traveling in a time of t? What did I say? If these waves hai na, if it has a velocity of v, mera bachcha log, in a time of t, how much distance will it be traveling? Very simple. Distance is equal to velocity into time, isn't it? Which means these waves will be traveling, all these waves will be traveling a distance of velocity into time. From the source, is this the only wave that is going to emerge? No. From the source, we can have a wave in this direction, we can have a wave in this direction. Matlab, if you want to collect all the endpoints of a wave emerging from a secondary source, what you have to do? Soch le, by the time I pick the color, soch le, what I have to do? Yes, by making this as a center, just draw an arc with a radius of what? Velocity into t, isn't it? So that you can find all the points which are at a distance of velocity into t, where all these can be the endpoints of the waves emerging from this secondary source. Similarly, you can draw an arc with a radius of vt for this point, for this particular point, isn't it? Why we are drawing these arcs? So that you can find out all the points which are at a distance of vt. Okay, all these points can be the endpoints of the waves after a time of vt. समझ में आ गया? ठीक है? All these are assumption once again. Now, what is said by Huygens? क्या बोल रहा है? He said that if you want to find out the wavefront after a time of t from here, let's say this wavefront was observed at a time of 0. Now, if you want to find out the wavefront after a time of t, what he said? He said that just draw a common tangent. We'll use another color, isn't it? Just which color will we use, मेरा बच्चा लोग? Which color? ठीक है, black use करेगा. Okay, he said that just draw a common tangent to all these arcs here. If you can draw a common tangent to all these arcs, you can find out the wavefront, okay, after a time of t. Okay, this is all. This is all what is explained in Huygens principle. What we learned now, I'll just recap. All points, secondary source. Waves emerging from secondary source, secondary wavelets. Right? In a time of t, the distance all these waves will be traveling is vt. Right? You draw an arc with radius vt. Draw a common tangent. What will you get? We will get the wavefront after a time of t. Very simple. Don't think much on this. कुछ भी नहीं है, just learn the Huygens principle as such, just by heart it, just know it, nothing more is there on this particular part. Okay, I don't want you to scratch your head like this, sir क्या बोल रहा है, ऐसे क्यों बोल रहा है. There was a time for me also, I scratch my head and thinking ये क्यों पढ़ रहा है मैं, ठीक है, लेकिन ये पढ़ना ही है. Okay, we have to learn this, then only we can proceed further. These are just assumptions, statements, okay, facts related to the wave model. Just learn it as such. Don't think. Okay, let me tell you, don't think. I'm gonna write it on a YouTube channel. ठीक है, don't think much. Okay, don't think much. कुछ भी नहीं है इस पे. Okay, learn it as it is. कर सकता है ना? Everybody can do it. Anybody? Everybody. Meara, क्लियर हो गया एवलीन का? और यस सबरीन, तन्मय, ऑल फेट्स, हाँ फेट ही हो जाएगा, ओके, बिकॉज दिस वाज माय फेट वंस अपॉन अ टाइम, आप सब लोगों का फेट अभी, ठीक है। आई डोंट थिंक इट्स अ बिग थिंग, राइट? हाउ मच टर्म्स वी हैव लर्न, नॉट मच कॉन्सेप्ट्स, राइट? उतना भी नहीं है, इजीली कर सकता है। बता, यस हेलो, अंडरस्टूड, यांत्या थकार, अंडरस्टूड, वेरी गुड, अमेजिंग। ओके ठीक है। अरे तन्मय बहुत सारे पीजेस मार रहे हैं आप क्लास पे, ओके, आई होप समवन विल बी देयर टू लाफ फॉर योर पीजेस, ठीक है। सर अपने इंटरेस्टिंग बना दे फिजिक्स, अरे वाह, अरे थैंक यू, ओके, नमस्ते शिखा। नाउ कोई डाउट है क्या इस टॉपिक पे, ऑन व्हाट एवर टॉपिक्स वी हैव डिस्कस्ड टिल नाउ? कोई भी डाउट है तो बता, कोई भी डाउट है तो बता, कुछ भी नहीं? अरे म्यारा इज तन्मय, म्यारा इज टेलिंग नोबडी इज लाफिंग, पता नहीं, maybe you should stop all these pages. Hi Shika, so bata, shall we proceed? No sir, sab clear? ठीक है ठीक है, okay, so moving on, moving on, we have some chotu questions, okay, chotu, because you know that we cannot do any numerical questions because I haven't taught you any formulas, which is not there actually, it is not because I haven't taught you, कुछ भी नहीं है, ठीक है। Now what I want every one of you to do is read the question and give me the answer. Good evening. Okay, answer, just read the question अच्छे से and give me the answer. What is it? The direction of a wavefront of a wave with the direction of propagation of wave. Propagation of wave means the direction of energy. Direction of energy is being shown by a ray of light. Question is, what is the angle relationship between wavefront and a ray of light? क्या हो सकता है? जल्दी बोल दे, क्या हो सकता है? What is it? Answer. अरे प्रतिभा, very good, perpendicular. Very good, very good. Yes, second option. I think so many. Evelyn Kaur, yes. Shika. और कौन? Lakshmi. Sabreen. अरे सब. Sakshi. Very good. Yes, it is perpendicular, right? This is very important because I have told you, मेरा बच्चा लोग, if this is a source of light, है ना? If this is what we are considering it as a wavefront, right? The ray of light will be emerging like this, where there holds a relationship between, an angle relationship between wavefront and ray of light as 90 degree, as simple as that. ठीक है? Simple, isn't it? तुषार, शिका, और क्या? Next one. Next, a wavefront is an imaginary surface where answer, इसका आंसर दे दे. A wavefront is an imaginary surface where which one? All particles lying on this vibrate in the same phase, an opposite phase, same phase, opposite, none of this. Very simple. Direct question पूछ रहा हूँ मैं, so that I can understand how many of you got the concept. Evelyn, Rainy, then which one? Myara, yes. Tushar, yes, it is option A, मेरा बच्चा लोग. Yes, because we already have discussed the wavefront is the locus of all points which are at the same phase, isn't it? Yes, and that is being said in the first statement, so that's our correct answer. I think A, yes, we have locked the answer as A. और कुछ नहीं, nothing more to think about it, isn't it? Okay, moving on. ये क्या है? The phenomenon of diffraction can be understood. I hope you do remember, right? I have told we are going to learn about some of the phenomena in this chapter, such as diffraction, interference, है ना? ठीक है? On what basis all these concepts are being explained? Just now we have learned, right? I'm just trying to revise by doing these one word problems और कुछ नहीं, ठीक है? These are not hard, very tough questions. हाँ, yes, it's option A है ना? Shika, Evelyn, Yanthia. It's not two then, मैं. Sabrine. Yes. Okay. So it's Huygens Principle. So we actually explained this particular diffraction by using Huygens Principle. Matlab all the whatever phenomenon what we are going to learn in this chapter is explained on the basis of Huygens Principle. Okay. Now do you know what we are going to do right now? आपको पता है क्या? What we are going to do right now? We are going to explain the phenomenon of reflection of light using wave concept, right? Because if a wave theory is a valid theory, or which means if light is traveling in the form of waves, right, it should be able to explain all the phenomena of light, isn't it? So what we're going to do is we are going to see is the wave theory can explain the reflection of light. Shall we do that? ठीक है. But chalo, in the case of reflection of light है ना, let's say this is a plane mirror. An incident light ray comes, this is called as angle of incidence. A reflected light ray we have angle of reflection. What is the simple principle of reflection? Angle of incidence is equal to angle of reflection, right? Matlab, this is the laws of reflection. So we are going to prove angle of incidence is equal to angle of reflection by using Huygens principle, or let's say the wave model of light. Can we do that? Are you all ready for our board exam? Direct theory question can come if it's a subjective paper gonna be. ठीक है? So पढ़ ले अच्छे से. I'm going to explain from the beginning by covering all the concepts. ठीक है? देख ले. I'm having a reflecting surface. What do I have? I am having a reflecting surface, I say. Okay. Then let us choose another color. Okay, this one. Now we know that a wavefront which is very far away from the point source, what was the shape? What was the shape of a wavefront which is very far away? It was a plane wavefront. Okay. So this is our incident wave front. क्या है? Incident wavefront. मतलब the wavefront directly coming from the source of light. Okay, it's a plane wavefront which I have shown. Now, as you all are more comfortable with the concepts of ray, I'm also drawing the ray of light also so that we can understand this in a better fashion. ठीक है. How can I draw a ray of light to this point? जल्दी बता. Very simple. Draw perpendicular to this point. This will be the ray of incident light at this point. At this point, what can be the ray of light? Just draw perpendicular as. Now, we have considered among all the different light rays, two light rays we have considered. दो, एक ये और एक ये. Okay. Now, listen बच्चा लोग अच्छे से, very अच्छे से, else you will not understand anything. I'm going to mark this as angle of incidence. No issues, I suppose. Okay. Now, देख ले, this light ray here, at this particular point initially when time t equal to 0, this was the position of the light ray at this point. Okay. Now, this light ray from here, let's say this is point A, this is point B, and this is point C. This light ray which was at the point B, let's say it takes a time of t to reach at the point C. Okay, it takes a time t. How will you mark this distance BC as? How can we mark the distance BC traveled by this light if it takes a time of t? A ray distance is equal to formula velocity into time. So if let's say v is a velocity, v into t is a distance. है ना? ठीक है. Coming back. Don't lose the concentration. ठीक है. So the light ray which was at the point B would be traveling in a straight line and reaching the point C. We were having a light ray at this point also. Tell me what will happen to the light ray at this point during the same time interval? Very simple. The light ray which is at the reflecting surface will get reflected. है ना? and how long it will be traveling? The same distance, because it also has the same time t and the velocity is also v. It will be traveling a distance of vt. But bachalo, though it travels a distance of vt, do we know the actual direction in which travels? No, right? Actually, we are going to explain this I is equal to r. Matlab, for the time being, we don't know in which direction this reflected light rays travel. So the reflected light ray can travel in that direction. Okay? Then the reflected light ray can travel in this particular direction or in this particular direction. In any direction it can travel, but it is that it should be having a distance of vt. Matlab, the end point can be here, the end point can be here. Matlab, if I just draw an arc ऐसे with a radius of vt, any point on the arc can be the end point of the light ray which is getting reflected from this point. Matlab, we are not able to confirm because we don't know in which direction the reflected light ray is traveling, है ना? ठीक है. Is there any method we can find out which is the exact point after the reflection? There is an idea. What is it? Use a simple concept, bachcha log, that ray is perpendicular to wavefront. Do you remember? Use a simple concept and then we have the answer in our hand. How? Arey dekh le, this is the point, है ना? Just draw a tangent to this arc here. Can you see that? Have you drawn a tangent? ठीक है. Now select that particular point on the arc. Okay, select that particular point on the arc which is where this tangent is touching. Let's say this is a point. Let's say this is the point where tangent is touching the arc. Now, have you understood which is our end point? ये होता है. How can we confirm that? Because if we know this is the reflected ray of light, it actually obeys the Huygens principle. What? The ray of light reflected and this reflected wave front which we have drawn, right, is actually satisfying that perpendicularity condition. ठीक है? It is actually satisfying that perpendicularity condition. So thus we can say that this is the point of the reflected light ray after it reaches, or this is the path of the reflected light ray. Is it clear? इधर तक clear है ना सबको? Is everyone clear? Right? We are almost at the end of this. Almost हो गया अभी. Okay. Last we are going to prove I is equal to R. हो गया. ये I है तो isn't this angle of reflection R? Isn't it? Yes. ठीक है. अब बता, ये I है तो बच्चा लोग, ठीक है, if this is I, you know that this and this blue lines are perpendicular. ठीक है. So how much is this gonna be? Which I have drawn just now. ये 90 minus I. So how much is this gonna be? I. Isn't it? ये I है, ये 90 minus I है, ये I होता है. No doubts I suppose. Similarly, this is R. ठीक है. Consider the triangle A. This is give it as D. ठीक है. Consider the triangle ADC मेरे पास. चलो everyone. ये angle 90 है. ठीक है. We already know. Now how much is this angle? Angle A of ADC. देख ले ये angle. ये 90. Okay. ये R. ठीक है. Because this is normal. So this is 90 minus R. So ये 90 minus R, ये क्या होता है? ठीक है. Now we just have introduced two triangles here and we have marked I and R. That's all. I hope you all can see. ठीक है. Done. हो गया. Now just consider the triangle ADC and the other triangle. This is ADC and a triangle ABC. Triangle ABC. What can you comment about these two triangles? Jaldi bata. ADC and ABC. What is it? What is it? Jaldi. Anyone? Can anyone make a comment? किसी को भी. Can anyone make a comment? These two triangles are from your small classes, chotu classes, isn't it? भूल गया. These triangles are called as congruent triangles. भूल गया सबने. These are called as congruent triangles. Why? देख ले, they have a common side of AC. AC is common. Okay. Then what do we have? Then देख ले, ये AD and ये BC equal है. क्यों? AD equal to BC. Why? Because both are velocity into time, velocity into time. देख ले, and one angle is 90 degree. One angle is 90 degree, more than enough to be congruent. ठीक है? So this angle I and angle R are opposite to the equal sides of VT, isn't it? Yes. So what we can say? Angle I is equal to angle R. Hence proved what? Reflection by using Huygens principle. That's it. Done, done, done. हो गया. हो गया मेरा बच्चा लोग, हो गया. और कुछ भी नहीं है. ठीक है. So actually at the last part of this, okay, at the last part of the proof, we were actually explaining or using simple concepts of mathematics, right? I was telling that two triangles are congruent, marking the angles, making the relationship between them, और कुछ नहीं. Okay, everyone, no problem. सर अब सॉन्ग याद है ना? अरे मैं तो भूल गया था. I was like somehow I'll escape. Tanmay sir, आज song. So we have one more topic, मतलब how to explain the concepts, right, of refraction using Huygens principle. So you want पहले song, then we'll go for that concept. Is that what you want? Is that what you want, every one of you? जल्दी बताओ. Is that what you want? जल्दी बताओ. Those who haven't liked the session, you all can do it. ठीक है? That's a simple way of showing love towards Ameer Bhaiya. Okay, so I'll just sing 2-3 lines. Obviously, the song which you might have heard so many times. ठीक है? 2-3 lines from one of the song, and then we'll continue. But you have to promise me, बच्चों. Okay, after we come back from the song, you should be fully energetic. Is that a promise? ठीक है? Fine. I don't know with this small chair you can see me, but let's hope. Okay, I hope you can see just my head, right? More than enough, I suppose. Okay. दो दिल मिल रहे हैं, दो दिल मिल रहे हैं, मगर चुपके दो दिल मिल रहे हैं, मगर चुपके सबको हो रही है, सबको हो रही है खबर, चुपके दो दिल मिल रहे हैं, मगर चुपके सांसों में बड़ी बेकरारी, आंखों में कहीं रत जगे, कभी खाने लग जाए दिल को, कभी फिर दिल ना लगे, अपना दिल को जरा थाम लूं, जादू का मैं इसे नाम दूं, जादू कर रहा है जादू कर रहा है असर चुपके चुपके. Okay. Okay, fine. Okay, so that was just a simple way Ameer Bhaiya has tried to bring back the energy. ठीक है? And I hope you all got a bit of energy from this small relaxing time. ठीक है? Nice singing. Okay, thank you so much. Thank you so much. Okay, so बता दे, are you with full of energy and to continue with our class? Everyone feeling relaxed? Okay, very good. Fine. I hope you all are ready. ठीक है? 2 million likes. That is something which is never ever gonna happen, है ना? Okay. So we're gonna continue. We are gonna continue, and what we are gonna continue with. But chalo, by using the concepts of Huygens principle or the wave model of light, we have explained the reflection of light right here some moments before, some time before, isn't it? And अब क्या बाकी है मेरा बच्चा लोग, अब क्या बाकी है मेरा दोस्त? Yes, explaining the concepts of refraction using the wave model of light or using Huygens principle. Are you all ready for that? It's very simple actually, very simple, right? Okay, let's get started. Everyone write the heading. Okay. Refraction using Huygens principle. ठीक है? P I have written as a short form for principle. छोटा space था. ठीक है? Fine. Now, when you think about refraction, what is the first law that comes to our mind? Snell's law. What is Snell's law? That is sin I divided by sin R is equal to N2 divided by N1. Isn't this? So when we think about proving refraction, right, when we're going to make a proof for refraction using Huygens principle, what should be our final result? That sin I by sin R is equal to N2 by N1, and that is exactly what we're going to do now. ठीक है? Ready? Everyone? Okay. Now write it down. I'm going to be having a line of separation. Okay? A line which separates two mediums. Here this is a medium 1 with a refractive index of M1, N1, and let's say light is traveling in this particular medium with a velocity V1. Okay. Now let's say this is a medium 2 and this is having a refractive index of N2, and let's say this is having a velocity of V2. Fine. Okay. Now let's say this is a rarer medium. Okay, and let's say this is denser medium. Is everything fine? Okay. Now, just like before, we are going to consider an incident wave friend. Everyone. So obviously, when we were learning the chapter of ray optics, we were always concerned with ray of light, right? So instead of a ray here, what we'll be having? Wavefront. So first, incident wavefront. This is our incident wavefront, right? WF for wavefront. Now, I'm also going to introduce the concept of ray here. Why? Because that is more easy to learn and more easy to understand. Now, at this point, I'm going to introduce a ray. How will you draw a ray to the point? Draw a perpendicular. Let me say this is point A. How will you draw a line, a ray at this point? Draw a perpendicular. Let me name this as point B. Now, initially, the ray of light was at the point A here. This ray of light was at the point B at time t equal to 0. ठीक है. Now this ray of light है ना, at the point B, let's say it travels and reach the point of the line of separation at the point C. ठीक है. And if I'm saying it takes a time of t, how much will be this distance BC will be? If it takes a time of t to move from the point B to the point C, how much will be the distance BC? Everyone, how much? Array distance is equal to formula velocity into time. So velocity is v1 in this medium into t, isn't it? Yes. Now tell me, everyone, tell me what will happen to this ray of light at the point A during this same time interval of t. Is it going to get reflected? No, it is going to get refracted into the second medium, right? Okay. Now, when we talk about the light ray is going to enter into the other medium, how much distance it is going to travel in a time of t? Array in this medium, velocity v2 hai. So the distance it is going to travel is going to be velocity into that medium into time t, v2 into t. Hai na? Now if I ask you in which direction, array we don't have any idea, because we are going to prove that if a light ray is traveling from rarer to denser, it is going to bend towards the normal. Now we don't know. ठीक है, अब हमको कुछ भी नहीं पता, we are going to prove the same. So the light ray which is at the point A during the same time interval of t, it can either travel like this, ठीक है, it can either travel like this or it can either travel like this. मतलब the end point of a light ray which is refracted into this medium, we can only say it can be at a distance of, what? v2 into t. Isn't that what we can only say? So I have simply drawn an arc with a radius of v2t. We can say that any point on this arc can be the end point of the refracted light ray, which we don't know. It can be 1, it can be 2, it can be 3. We don't know. We don't know which one it is. So what will we do? Array, as we all know, we'll be drawing the refracted wavefront. This is the incident wavefront and we are going to draw the refracted wavefront. Kaise? How? Kaise batao? Kaise? Yes, just draw a tangent to this particular arc here. Okay, so I'm not so good in drawing. Okay, so you can see that the refracted wavefront, if we mark it, refracted wavefront, if we mark it like this, refracted wavefront, it is touching this curve at a point. So it is at this particular point, the refracted wavefront is acting as a tangent. इसका मतलब क्या है? इसका मतलब ये है कि मेरा बच्चा लोग, ये light ray, okay, and this refracted wavefront will be perpendicular to each other. Now does it obey Huygens principle? Yes. So if it obeys Huygens principle, which one can be the refracted light ray? Ye or ye? Third one. So this is going to be our refracted, ठीक है, light ray. Any doubt? इधर तक कुछ भी नहीं है ना? So if you understood till here, what is only left is a bit of geometry. हो गया. If we just want to do some geometry, उसके बाद this particular thing is over. कर सकता है? Shall we do that? Okay, last one हो गया तो हो गया इसके बाद. Okay, देख ले. What is this? Angle of incidence, right? How much is this? 90 minus I, because this incident wavefront and light ray are 90 to each other. If this is I, 90 minus I. देख ले, this is horizontal, ये तो normal है. Normal is 90 minus I, so ये तो I ही होता है. ठीक है? Now considering the triangle ABC. Triangle ABC, what is sine I? Tell me what is sine I? ये sine I, ये तो 90 है. Sine I is opposite, that is BC. BC is equal to V1t. I'm going to write it directly. V1t, the whole divided by hypotenuse. This is 90, so this has to be our hypotenuse, which is AC. Okay, done. First part is over. Matlab sin I, we got it because we want sin I by sin R. Okay. Now we have to go for R. Isn't this angle of refraction? Yes. Isn't this 90 degree? Yes. If this is R, how much this will be? 90 minus R. So ये कितना हो जाएगा? R. No doubts, right? ये 90 minus R, R. Can I take sin R? और क्या सर? बिल्कुल कर ले आप. आपका मर्जी. Sin R तो ले लिया. Going for the triangle. Okay, I'm going to name this as D. Triangle ACD. Triangle ACD हो गया. Sin R ले ले. Sin R, ये R है. Taking sine, opposite AD. What is the distance it travels? I have already told you. AD is V2T. ठीक है. V2T divided by, ये तो 90 है. Opposite is hypotenuse. So sin I is opposite divided by hypotenuse, that is AC. Is it clear till this part? Yes. Now, if you name this as equation 1 and if you name this as equation 2, हो गया मेरा बच्चा लोग, काम तो हो गया बिल्कुल. What we have to do? Equation 1 divided by equation 2. कर सकता है? हाँ, कर ले. So, equation 1 by equation 2, what is it? Sin I by sin R is equal to, अरे T cancel, AC cancel, what will we get? V1 by V2. You will be like, sir, still we haven't proved Snell's law. What is there to prove than this for Snell's law? Kuch nahi. What I'm going to do? I'm going to multiply C on the numerator and denominator. Arre. Okay, we did sin I V1t, sin R V2t. So opposite sin I by sin R is V1. Okay, done. Now, your responsibility. Tell me what is C by V2? जल्दी से बता, ये देख ले. What is C by V2? Array, that is N2, right? N2. Now, here we have this C remaining. देख ले, ये C. This V1, I'm going to take it downward. So it became C by V1. What is C by V1? Isn't it N1? Yes or no? Writing down the left hand side as it is, sin I divided by sin R. What do you got? N2 by N1. And what do you got? We just have proved the Snell's law or the refraction by using what? By using what? By using Huygens Principle or the wave model of light. Matlab, using wave model of light, we can explain a reflection, a refraction, and whatever we are going to learn in tomorrow's class, interference, diffraction, kuch bhi aa jao, we are going to crack with wave nature of light, because that is how actually the light is existing. समझ में आ गया सबको? समझ में आ गया सबको? क्लियर है Huygens Principle to everyone here? जल्दी से बता, जल्दी से बता. Simple था ना concepts. I know that it was completely with full of concepts and all, but still, did you all enjoy? All clear, Evelyn? Done, Yandya? आ गया तो आ गया. Crystal clear. Now, tell me, how many of you are going to be totally regular to the class? Matlab, every day who is going to come to the class, take down the notes, do some extra MCQs. Okay? Tomorrow onwards, we'll start with numericals, because from tomorrow onwards, we are going to be having much of formulas to learn. Okay? So everyone, simple, dimple, all clear. Lot of concepts. Yes, like I said, this is going to be a conceptual chapter, right? So for doing some numericals, we have to cover much of concepts. I hope you're ready. We have to learn this chapter, right? Na? Important chapter, like I told you, many questions are going to come. So it's an important chapter, right? Okay. Myara is like, sir, take attendance. I'm gonna be there 100% attendance. बिल्कुल बढ़िया. 100% regular. Okay, so I got so many students here who's gonna be totally regular to the classroom throughout, right? Not going to be late, not going to be absent every day. ठीक है? Very good, Pratibha. Very good, amazing. Now, tell me, how can you show some love towards Ameer Bhaiya? How can you show some love towards Bhaiya? Huh? Jaldi se move your cursor and click on that like button and do let me know that you have enjoyed the class, understood each and every concept. And those who want to write it down, jaldi se write down kar le. And like I told you, I'll be updating the notes in the Unacademy class 11th and 12th Telegram channel, so don't worry about it. Pratibha, every day. Okay, Evelyn, every day. Very good. Like, share, and subscribe. So everybody is giving so much of. Okay. Now, bacha log, chapter revision through MCQ. Matlab, you know the chapter ray optics, right? Okay. So how we are going to learn this? But we already have done the classes, right? We are going to make a revision. How? Right? By doing MCQs from each and every topic. So you'll be having that plus point of learning the concept and doing MCQs from the topic and learning ray optics. Matlab, we can complete within 2 classes. Part 1 will be done on which day? On 5th of January, matlab this Wednesday at 4:30 p.m. Okay, on this particular Wednesday. And where you can see this particular class, array, it's very simple. It is going to be a special class. Now, are special classes paid? No, special classes are completely free. Special classes are completely free. Okay, those who don't know how to join, what you have to do? Very simple, I'll tell you. You just have to download the app. Download the app. ठीक है? After downloading the app, क्या करना है? Just download, log in, okay, then go to menu. From the pop down menu, just click on specials, okay, and then just type in the unlock code, which is AMB10. Okay, so after you type in, chalo, you can get access to this particular class completely for free, bilkul free. Okay, so don't miss this chance. So I'm going to expect Wednesday, those who haven't enrolled, jaldi enroll kar le. It's free. It's the Unacademy app, free, bilkul, right? The best way to learn this chapter of ray optics. Don't miss it. Okay. Now, this is the first part. On 6th, matlab on the very next day, Thursday, we'll be having the part 2 of the same chapter, ray optics. So don't miss it. Okay? So come and attend to this class at 4:30 to 5:30 p.m. Okay? So yes, moving on. Mera bacha log, let me tell you, offers are going on. Khoob sara offers, because you know it's 2022, the last day where you can get 22% off. How? Just use a code while you make the subscription. Mera bacha log, it is AMB10 is our code. Get 22% off when you make the subscription. At the same time, for the first 1,000 subscribers, if you go for 12-month subscription, extra 6 months is given free. बाप रे ये और 22% वो क्या है. So I think this is the best chance to make the subscription. Don't miss it. जल्दी से, ठीक है? Now these are the other batches. What you can see here, right? Expedition batches for term 2, Spark for term 2 science, right? So don't miss it. This is for class 12 and this is the other batch. So you can be a part of it. Special class timetable, I already have shared it with you. Why special classes are so important? Because we can have uninterrupted live chats here in this class, question tabs where you can put your doubts and I'll be clearing it out. Live polls and quizzes will be there and leaderboards will also be there. मतलब बहुत मजा आ जाएगा once you are a part of this special class. Now it's time to show some love. कैसे? Just move your cursor, click on the like button and do let me know that yes, you enjoyed the class, understood each and every concept, and tomorrow you're going to be there on time without being late. Okay? Jaldi se show some love. and you all can share it with your friends and tell them that Bhaiya's class was good and this is the best time to start with the chapter of wave optics. Tell everyone, okay? And do subscribe. You all can subscribe to the channel so that you won't miss any of the live classes. Okay? Okay. Yes, Sudeep, Miara, thank you so much for the support here in the chat box. So I think it's time to say good night. बहुत भूख लग रहा है मुझे. I'll just go run and eat something. And I want every one of you also to do the same. ठीक है? Yes. So bye everyone. फिर मिलेंगे चलते चलते. Isn't it? This time it came correct. Okay. So bye everyone. Thank you. Good night.